So for our project, we're going to have a set of 3 buttons connected to 3 LEDs. And those LEDs are also going to be connected via the code to a series of lamps on the app interface. And the reason we're doing this is to sort of make like to emulate a rhythm game, in the sense that they're going to be a sequence of lights that each turn on and as it goes down the line until it reaches the LED. And when it reaches the LED, the player is supposed to press the button. If they press the button when the light's on, then they'll gain a point, and if they press it when it's off, then they won't. So we're basically going to have some adaptive difficulty with the game, and the way it works is there's going to be 10 levels. Basically, the player at the start can choose what level they want to start at, with easy, medium, or hard. Easy starting at level 2, medium starting at level 5, and hard starting at level 8. And there's going to be a difficulty check around every 10 seconds in the game, and what that difficulty check is going to do is it's going to see, was the player, did they have a 90% success rate, a 90 to 70% success rate, or a less than 70% success rate. If they have over a 90% success rate, they will move up a level. If they are between 90 and 70%, then they will stay at the same level, and if they are below 70%, then they'll move down a level. On the screen I have the 10 difficulty levels. Basically, level 1 starts off with only 1 note at a time, and it goes very slow. And you can only really get to level 1 if you're having trouble at easy mode. Level 2 is 1 note at a time, and it's slow. Level 3 can be 1 note at a time, and it's medium. Level 4 is 1 note at a time and fast. And then we get to level 5, where there can be 2 notes on the lights at the same time, and it's going to be a medium speed. Level 6 is 2 notes at a time and fast speed. Level 7 can be 3 notes at a time and medium speed. Level 8 can be 3 notes at a time and fast speed. And then level 9, which you can only get by being pretty successful in hard mode, can be 3 notes at a time and very fast. And the last one can be all the lights could be full potentially, and it's very fast. We're going to have a random % chance that you can have more than 1 note be full at a time, and we're still working on the exact values per level, but that's just the general gist of how the LED, lamp, and button system will connect together with the score for adaptive difficulty.
In this project, I'm taking charge of the LCD control, and we are going to use the LCD screen to show some basic information like the welcome message and the number during the games. Also, we are using a driver to control the LCD, and all the message will be managed by the time and shows at the time when the games are playing.
What you see here in this mess is one of the moving components of our game projects. This is a motor. It's powered by a motor driver, and let me power it. What this is going to do is, well, it's going to move, and we're going to have it move according to inputs from our game app. So basically, when the user gets a series of notes right, it's going to move one direction to signal something affirmative, like flip up a good sign, and do the converse if the player does something bad. And this kind of logic, along with various servos, is what is going to be the animatronic interactive part of our game project. It's going to look much cleaner than this because I'm going to build carapaces and make it look pretty, but for now, yes, this is the motion aspect of our game. In terms of feedback, what we're really looking for is how to make this servo setup and this motor setup more aesthetically pleasing to users, and how to have it actually signal good versus bad results in the game. Because this motor only has back and forth rotational capability, and the servos themselves only have limited range of motion. So outside of making a pretty external shell to house this mess of wires, we're also looking for user input on what they would like to see as a physical representation of their gameplay.